Good evening, everyone. My name is Claire with my colleague Emma, and our topic is weekly and self-supervised learning in ECG, voice translation. And yeah, and the keywords are weekly supervised learning, self-supervised learning, ECG signal processing. ECG is electrocardiogram and speech generation. And we're starting with the weekly supervised learning. This is the training of a model using partially labeled or noise data where labels are not fully accurate or comprehensive. Okay, this one mainly is about where a small amount of data is labeled and a large amount of data is unlabeled. And the model learns from both the labeled data and the patterns in the unlabeled data. And sources of data, we have weak labels. We use weak labels like incomplete annotations, noise labels, and also heuristics or indirect supervision. And we have the types of weekly supervised learning. We have the incomplete. This one, only the subset of the data is labeled, like allows a model to learn from both the labeled and unlabeled, like the way it is shown here. Part 2 is labeled, okay, 2, 3, and 5 are labeled, but 1 and 4 are not labeled. So this allows the model to learn from the labeled, like the run, and the unlabeled here, part 4 is not labeled. So it is easy for the model to learn from them. Then we have the inexact data, the inexact where both are named, like the data is post-grain labeled. Like the meaning of this is that the data is labeled with broad or general categories, like the data is given a general name, not detailed names. Like here you're given people are running and others are jumping, but they are not specifying that they are not giving them their real names because they are generalizing the thing. Hope you're getting me. Then we have another type of weak supervised, which is about the inaccurate. The labels are not always true. Like you see this number 2, there is run, yet it is wrong. The person is high jumping. And part 3, it is wrong. The person is actually running, it's not high jumping. So that one, like real world data is often messy and contains errors. Training with inaccurate labeled data can make a model more robust and to noise and inconsistency in data, hence improving the performance of tasks in the real world by the model. And we have examples of weekly supervised learning. We have the image classification with bounding boxes, like as it is shown there in the image. Like if the model is trained to detect cars in the road using the bounded boxes like those ones on the car, instead of the detailed masters, like this reduces the annotation effect or effort while still guiding the model. Hope you're getting me. And we have another one, which is text classification with keywords. This one, instead of labeling every document, model uses a set of keywords, like as shown here in the diagram. Like it is unethical, but the model is using technology, sports, and entertainment. Instead of labeling everything, the model uses those words to categorize everything in the article. And another example, we have labeling via heuristics, like here, by applying simple rules to automatically generate labels for a large data set, like maybe spotting spam emails, like in the image there. If the model maybe detects the word like free, like win or lottery, it knows that this one is it is a spam email according to the words like free, lottery, or win. And we have supervised learning, and this involves training a model using it involves a model creating labels directly from unlabeled data itself, and the sources are labels from the data itself. Okay, here a model is trained on unlabeled data to generate a pseudo labels. The model uses these labels to train itself in subsequent iterations. The model's performance improves each iteration. And we have the examples of self-supervised. We have the image rotation. This one is all about a model predicts the rotation angle of an image. Like, let me say, training a model to predict the rotation angle of randomly rotated images. It helps learning features about the image orientation, like in the image provided. Then continuation, we have jigsaw, another example of self-supervised learning. We have jigsaw puzzles. Here, a model learns spatial relationships by reassembling image pieces. Like that jigsaw puzzle, the images are broken down into small pieces. So the model is tasked to reassemble that puzzle into a real image. So another one, we have a contrasting learning. This is all about comparing different augmented versions of an image to learn representation. Like in the image provided, it is a cat, all of them are cats, but they are presented in different versions. So a model is going to be trained to identify a cat in different versions. So it is given in different versions. So I'm sure the model will learn how to identify a cat if it is provided such an image. Thank you. Let me invite my colleague.
Good evening, everyone. This is Emmanuel Asimwe. So I'm presenting weekly supervised learning as used in our project. So weekly supervised learning is a kind of machine learning that is used on weak models. It's used to run models that are actually weak, and we are going to use labeled data. So we're going to have raw data that is going to be fed as the user input into different algorithms. That is a software that is going to be trained using a training algorithm to obtain our required model or data set that is predictive. So with weakly supervised learning, we're using weak models and labeled data to train the given data set or model. So with weakly supervised learning works best because in most cases, we do not have the available data set that is entirely complete. So weakly supervised learning is most of the times used because data sets are always not available to the full extent. Then we're going to look at the objective. So we were working on a project to aid the voice impaired individuals or speech impaired individuals aid them speak effectively. So our objective was to convert ECG signals into voice to help speech impaired individuals. So we faced a lot of challenges in the process because we had limited label data. In the end, we ended up with using only uh, speech speech of children, like a data set we got was health, health of patients who are kids. So these kids, we had sick patients and also had healthy patients. So these kids we had their audio clips, and these kids would produce different sounds so that we can recognize a pattern. So the challenge we had was we could not access data for grown-up people who are very sick. The only data set we could have was for the sick children. Then the noisy mappings. So the data set itself that we got, which was actually limited, also had issues. So you could find that some data set had issues with the noise, some data set had issues with itself. So the data was not very good. Then learning meaningful representations. So one of the other challenge we had was we had to extract meaningful representations out of the data we had. We could not use the data very well effectively because we had to extract meaningful representations out of those funny noises that the kids made. Then the other thing you're going to look at were the challenges in the ECG to voice translation. So the challenges we face in ECG to voice translation, we had lack of labeled ECG to speech datasets. So we did not have ECG to speech datasets. We struggled to get them, though we managed to get one in the end. Noisy labels in real world ECG data, that the labels were noisy themselves. Then high variability in ECG signals. So the ECG signals were highly variable. You could find an ECG signal that is efficient, and then you could also find another ECG signal that is very terrible. So there was a high variability in the ECG signals. They were not consistent. One was extremely good and one was extremely terrible. So this high variability was a challenge to us. So we could not effectively utilize the signals. Then difficulty in learning direct ECG to voice mapping. So we also had the challenge of learning direct ECG to voice mapping. So why should we opt for weekly supervised learning? So we were training with partially labeled, noisy, and incomplete data. Actually, in the real world, it's very difficult to get data. Data is an asset. So the data set we had was incomplete, and it was partially labeled, and it was also noisy. The weekly supervised learning would be the best alternative because it would reduce labeling costs and leverage weak labels for training. So this is why we opted for weekly supervised learning. So using weak labels, so we were pairing ECG signals with their approximate speech labels. So we would pair a signal with that speech label. That's how we were using the weekly supervised learning using their weak labels. So then we're denoising. What we're using to denoise? So we're actually minimizing the noise from those speech patterns so that we can extract out the meaningful representations. So we use confidence-based learning to refine noisy mapping. And techniques in weekly supervised learning for ECG signals. So we use multiple techniques, like graph techniques, like those multiple techniques to extract out the ECG signals. So we have graph-based learning. So we were using ECG signals to infer missing labels. Then you had multiple instance learning. We were learning from ECG segments. Then we have self-training. We're generating pseudo labels for unlabeled ECG signals. So next we were having solutions to be used in weekly supervised learning. So for noisy ECG to voice labels and incomplete data sets, we use the following solutions. Weak supervision using related data and label correction with confidence scores. So we use these two solutions to reduce on the noise, and then we use label correction to reduce on the incomplete data sets or labels. Then we shall go to self-supervised learning. So self-supervised learning in it is a very, very strong learning technique, machine learning technique, because self-supervised learning uses models and trains them to be autonomous or independent. So what we do with self-supervised learning, you're going to have raw data as the input, And then we are going to extract features, data features out of the raw data or data set. And then you're going to give the data features extracted out to a feature learning model. We're going to train this data based on those features. But then the model itself is going to train so that it's autonomous, it's independent, it doesn't depend on the data. It trains itself repeatedly based on the data, but we give it tasks so that the task can train the model to be efficient and robust in what it does. So we're using the self-supervised learning to train an autonomous model that does not need labels. So we just use pretext tasks to train the model. So we have task transfers so that the model is good at prediction and generate perfect labels to be used in carrying out its potential aspects. Then why self-supervised learning? So as previously defined self-supervised learning, the model is going to be autonomous and independent. So yes, it's a good thing, but then it's also a challenge because now this is when it brings about the danger of AI, the terrible things AI could do, because if it's autonomous and independent and thinking on its own, because now people believe that if we are doing self-supervised learning, the model is going to be independent. It could gain consciousness. So it is a weird thing. So people are nervous about that and they fear that AI could take that trend. And then why self-supervised learning? So we are learning from raw data by generating labels through pretext tasks. So you're going to get the raw data, put it in a feature modeling algorithm, and then give it pretext tasks to generate labels. So that's how self-supervised learning works. So you're going to learn meaningful representation without manual labeling. For weekly supervised learning, we're inserting the labels ourselves. So it was actually a hectic thing for us because we were doing the manual labeling. And then, well, for self-supervised learning, we're going to learn meaningful representations without doing the manual labeling. Then self-supervised learning in ECG to voice translation. So we're going to pre-train on unlabeled ECG data to extract meaningful features. That's what I was talking about. We're going to fine-tune with small labeled data for ECG to speech mapping. So techniques in self-supervised learning for ECG signals. So you have predicting missing segments, mass ECG modeling. You have temporal order prediction, learning signal sequences. Then you have contrastive learning, differentiating between similar and dissimilar ECG patterns. Selective learning. So with contrastive learning, it's about, like, for example, if I have a cat and a dog, and someone can actually tell this is a cat, this is a dog, they can tell that these are dissimilar objects or animals. But then if maybe they have a cat and a cat that's rotated, so they can easily tell that this is a cat, but this is a cat that is rotated. So they can classify them as both cats, only that they can also tell that this was rotated and this was not. Then solutions in self-supervised learning. So for self-supervised learning, challenges like designing effective pretext tasks and aligning ECG features to speech features, these strategies were implemented, all these solutions. So you're going to experiment with multiple self-supervision learning strategies. Then you're going to use domain application techniques. So I made a comparison of weekly and self-supervised learning. So for the supervised learning, you're going to have a feature. So for example, labels. So weekly supervised learning, you're going to use noise and weak labels. For self-supervised learning, you're going to generate labels from data. Then the goal for weekly supervised learning, you're going to improve learning with weak algorithms. And for self-supervised learning, you're going to learn representations autonomously. For example, weekly supervised learning uses ECG signals for approximate labels and self-supervised learning uses pre-training of ECG signals. So as we previously discussed, weekly supervised learning is going to improve with weak algorithms. Then this one is going to learn autonomously because we are going to give the data to teach itself, train itself, but based on the given pretext tasks for their self-supervised learning. Then, so a hybrid approach. So it would be better if we combine the strength of both, the strength of both models. We're going to combine the strength of the weekly supervised learning and the strength of the self-supervised learning. So we're going to combine the strengths so that we can achieve better results. We're going to use supervised learning to pre-train an ECG encoder and on unlabeled data, fine-tune using weekly supervised learning and weekly labeled ECG to speech pairs. So we're going to use active learning and refine predictions. So implementation. So here is some sample code that we use, and we import useful libraries in the the exploratory data analytics. We imported the OS library. This was for file handling, and the browser was for feature extraction. This is for displaying the features. NumPy was for statistical analysis and numerical numbers, and Pandas was for data structures. So MATLAB was for the waveforms and so many others. So in the implementation, in the code implementation, so we had, I gave you a sample code of a waveform. So we defined the waveform by attaching a file path to a title. So you're going to load each audio clip into the file path. Then you're going to plot a figure of this size. You're going to have a length of maybe 10 and a width of 4. Then you're going to extract out features and display them into the audio file. Here we're extracting out features. Then you're going to plot a title. You're going to plot a title of the graph. It's going to be there. Then you're going to label the x-axis with this plot plt.x label as time in seconds. Then you're going to plot the y-axis with plt.y label with amplitude. And then you're going to display the waveform as shown. So then you're going to okay. So you're going to this plot wave df class is equal to healthy file. So here we're extracting out the healthy sample, and here extracting out the sick patients in this SLI speech sample. So then I will summarize with this. So future improvements and research direction. So we have better pretext tests by finding optimal self-supervised learning strategies for ECG. We have domain adaptation by aligning ECG with different speech patterns. Then larger dataset by expanding ECG to voice corpora. So actually, the future improvements with this is to convert the voice patterns we get, convert them to a screen, maybe text that will be displayed on a screen. So if this is, we have the available data sets and we will be able to use them to modify the available data to expand to that extent. That would be a better foundation for AI, because this would allow us to do telepathy and mind reading. Then I'll conclude with this. The weekly supervised learning and self-supervised learning help overcome limited labeled ECG data. Hybrid methods improve ECG to voice translation accuracy, and future research can refine techniques for real-world applications. So this has been Asimo Emmanuel, and thank you for this.